oops, sorry. Here we go. All right, so what you're gonna put in to start you off is your perfect squares, your perfect cubes, and your perfect fourths. Like I said, you can use your calculator to generate those values for you. Like if I want to do the fourths, I'm just going to put in the second equation. I'm going to do x, raise it to the power of 4, and then hit second graph. And then these are my perfect fourths. Okay, so if you want to record those on your sheet, you will get to use your review sheet on your tests, and we will break down these questions. The review will be a separate grade. I'm going to go over a couple in each section or each row, and then let you finish a couple to see how well you understand the material, and then we will have the test tomorrow. Okay, I prefer that you turn it in so that I can just give it right back to you with your test. Because if you lose it, I can't provide another one for you. Okay. So you need your perfect cubes. Let me get caught up with y'all. And then your perfect fourths. I probably should have done that in a different color. All right. So 125, 216. We're using these numbers to simplify. The front page is just simplifying. I'll review that with you again. And then change that to green. And then the back page is solving equations, which is what we did the last couple days. All right, so 1 is always a perfect square, cube, fifth, doesn't matter. It's your multiplicative identity. 81, 256, 625, 2401. All right, and I'm just gonna do dot, 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 dot. Okay, so the first one is just all possible roots to the radical below. We're just putting this in the calculator and getting the answer. So to recap that, let me clear this. To do the square root, you have to hit second and then x squared. Okay, and we're just putting that in, 225, hit enter. There is our answer, 15. Okay, if it's a perfect square, it should be a whole number answer. If it's not, and you get a decimal, that means you have to simplify it. So, because we're talking about square roots, come on, where are you? There we go. This will be plus or minus 15. If the index, the exponent we're dealing with is even, you have a positive and negative answer. Okay, so to do the cube root of 512, this is when we have to hit math, and then we can pick number 4 to do a cube root, and we get just 8. So if it's odd, you do have to pay attention to your signs. I have to do that in blue. Like for example, this next one, we're doing a negative, the cube root of a negative 64. So when you hit math, or you need to put negative 64, and you get negative 4. Yeah, this one's going to be negative, okay? All right, so negative 4. All right, y'all can take care of the last one. The fourth root, for that, you have to indicate the index. So you're going to pick number 5, and then you're going to put the index 4 outside the radical, and then type in the number. Okay. All right, so now we're going to get into simplifying radicals. Did everyone get, what was it, 6? Number 4? Did y'all get this one? Yes or no? Are we okay on that? Yes. Okay, all right. All right, so this is taking the square root. Well, if I just start off and said, okay, what's the square root of 150? Oops, that's delete. Let me get that out. Square root of, it's gonna come out to be, come on, radical. Oh, I keep hitting alpha. That's my fault. There it goes. It's gonna come out to be a decimal, which indicates I need to simplify it. So to simplify it, I'm trying to find a number up here. Let me get my pen. In this first row, that would go into 150. 25. Yeah, 25 is the largest number. It's a perfect square. Like I can check, it needs to divide evenly. 150 divided by 25. There are my factors. So when you divide it, you can't get decimal answers. So we're going to break this down. What's outside the radical, this 5 here, will stay outside that radical. We're just going to show the factors. This is how you can receive partial credit. This was 25 and 6. Okay. Show the factors. So write that down. Then the perfect square, we want to square that number because that number is going to go away. And it's going to come out. So the square root, I'm going to draw a line through a 25. The square root of 25 is 5. It's on the outside. So really I got 5 times 5. And what's not the perfect square stays underneath the radical. So this gets simplified because you're going to multiply what's outside the radical as 25 root 6. So we're still doing square roots here. I'm supposed to do that in red. Sorry. All right. We have 8 on the outside. It's a -8. We want to keep that there on the outside of the radical. What perfect square? What number here? Huh? 9? Yeah. 9 times 7. Yeah, 9 times 7 would give me 63. And then 9 is the perfect square. So that's gone and comes out as what? Yeah. Okay, so now we're multiplying these two numbers together. This would be a -24 root 7. All right, so now they want us to do the cube root. Okay. So now I need to look at this next row. And 875 is not a perfect cube, but what number in the middle row could go into 875? Yeah. So would you just check, just go through and divide them by the numbers in the row. Yep. And make sure it divides evenly. So I'm just going to simplify that. 125 times 7. Okay. The 125 is the perfect cube. What is the square root, or the cube root, excuse me, of 125? Yeah, it would come out as a 5. So this would be 5. And then the cube root of 7. So if there's a number outside, you got to keep that number outside the radical. You got to keep that number out there and just multiply it to any perfect root that you take out. So kind of want to jump to number 9 because now we're looking for the 4th root and we have the coefficient -3 on the outside. So because we're doing the 4th root, I'm trying to find a number in this row that goes into 567. So you have to divide 567 by one of these numbers here. You might have to guess and check. Yep. All right, so our factors are 81 and 7. 81's the perfect 4th root. So this is the one that's going to come out. And the 4th root of 81 is 9. No, 4th root. All right, so we're going to now multiply these together. This will become -9 outside the fourth root of 7. All right, so let's now talk about when you have variables, okay? So you're going to do the numbers the same, but now the variables is when we're going to have to divide by the index. We want it to divide into it evenly. Remainders will stay underneath the radical. Your quotient will come out. So like on number 11 here, we have 3 times the square root of 252, x to the 5th power. So I'm just going to do my number and then my variable. So the number I'm breaking down into factors. I want a perfect square factor that goes into, all right, 36 times, 36 times 7. Okay. Keep that 3 outside. Now here, the index of a square root is 2. So all I'm doing is dividing the 5 by 2. How many times does 2 go into 5? 2 times. Okay, so that means that 2 is coming out. And do we have a remainder? The remainder of 1. That 1 remainder is what's staying underneath the radical. So this is our perfect square. That comes out as 6. So when I simplify this, 6 times 3 is 18. Then we had k, 2, because we took 2 out, right? Then we have the square root of 7k, 1 remainder that stayed underneath. Okay? This is our simplified answer. So this is the same premise. Now we just got 2 variables. The 4 is staying out. Okay, so what factor or perfect square? 4 and 15. Okay. Then I keep my a, and I have a power of 6, and I'm dividing that by 2 because the index is 2. And then my b, it's like having an exponent of 1 divided by 2. So 4 is the perfect square. Square root of 4 is what? 2. So the 2 comes out. Okay, so that's 8. There we go. We have our radical. We have 15. Now, oh, I forgot. Can 2 go into 6? Yeah. How many times? 3. 3. So that is, I should have made some room here. Sorry. Forgot that that's coming out. 8a to the 3rd. Because 2 times 3 gave us the 6, right? Now, can 2 go into 1? No. So that b stays underneath the radical. Okay. Now, this is the same premise even if we have a cube root. Okay, now the index is 3. So we're going to end up dividing by 3. So if we look at number 14 here, the index is 3 here. That 2 is going to stay outside. I meant to do that in blue. All right, so I need a perfect cube that goes into 64 times what? 3. Times 3. All right. Then I'm going to look at my variable 7 is going to get divided by 3. And q that has a power of 18 is going to get divided by 3. 3 can go into 7 how many times? Yeah, twice. So 2 times with the remainder of 1, right? 3 can go into 18 how many times? 6 times. 6 times evenly. All right, so now I can just simplify this because this cube root is going to come out. Let me clear my page, guys. What's the cube root of 64? 4. 4. Okay, so we have 4 times 2, that's 8. P to the 2nd power, Q to the 6th power. Then underneath our cube root, would be 3p. The remainder stays underneath the radical. Okay. All right. Flip over, we're going to look at some fourth roots. So now our index is 4 here. So first I want to see, is there a perfect fourth root that goes into 243, excuse me. All right, 81 times 3. Then I take my variable m that has an exponent of 5, and I'm dividing that by 4. Take my other variable n, has an exponent of 13, divide that by 4. So how many times does 4 go into 5? One time, with the remainder of 1, right? How many times does 4 go into the 13? 3 times, with the remainder of 1. Okay. 81 is the perfect fourth root. The fourth root of 81.
Sorry, no, it's 3.
Yeah, it's 3. Yeah, 3 comes out. So what we're gonna have is 3. Then our m, because it had 1 time, n to the third power, it went in 3 times. Then we have our fourth root of 3mn. Our remainders stay underneath the radical symbol. Okay. So there's 2 topics. We're going to assess. You're simplifying the radicals, and then you're solving your equations. This is basically reversing of what we're doing. Before we're taking the root, now we're getting rid of the root by raising to the power. So on here, number 20, in order to solve it, the radical has to get isolated. So like the first step is always, I need to put that in red, is to isolate the radical symbol. Get that symbol by itself. So if I'm like looking at this symbol, the 5x minus 1 is underneath the radical, but this plus 4 is not. So you would have to first subtract 4 on both sides of the equal sign. Now my radical is isolated, so the 5x minus 1 is going to equal to 7. Now I'm going to get rid of the square root by raising both sides to a power of 2. That will basically get rid of this radical symbol. So I have 5x minus 1 equals 49. We're solving for x, so we're going to add 1 to both sides. Our 5x equals to 50, which means x equals 10. So on 21, the square root is over the m plus 12. So to isolate that, we first need to get rid of this 1. That's going to leave me with a negative 2. Root m plus 12 is equal to 4. And now I need to get rid of this coefficient of 2. This is like getting multiplied to the radical. So the inverse of that is dividing by a negative 2. So now I can cancel and get my square root isolated. So the root m plus 12 equals negative 2. And now we're getting rid of the radical. So we have to raise both sides to the power of 2. So this now gets rid of this radical on the left side. So we have m plus 12 equals 4. And now we're just solving for m. If they're not showing you a radical, but they show you the fraction exponent, that's like the same thing. It means that 1/3 to the power of 1/3 is the same thing as taking the root 3. we're just still going to get rid of this by raising it to a power of 3. Yes? No, it's in parentheses. Mhm. Mhm. Okay. All right, and then don't forget, we'll talk about it. We'll come down here on 24 and 25. This is 1/2, so to get rid of that, I'm going to raise it to a power of 2, which means I'm raising the k to the power of 2. This will get rid of the fraction, so I have 18 plus 7k equals k squared. So when you have an exponent of 2, to solve it, you have to factor. Just when we're using our X puzzle. Yeah, we want it equal to 0, so minus 18 here, and minus the 7k. When I do that, these will cancel, so I have my 0 equals k squared minus 7k minus 18. Now I can go straight to my X puzzle. What number will go on top? Yeah, negative 18. And then negative 7. So we're looking for factors of a negative 18 with the sum of a negative 7. Yeah, negative 9, positive 2. So since these are the factors right here, my solution, k, is just the opposite of those factors. So it's going to be a positive 9, negative 2. You still want to isolate the variable, the square root. So number 25 will require you to add 4 first to get the radical by itself. So we have the square root of 6x plus 19 equals x plus 4. This is the one when we get rid of the radical by squaring it, you're going to have to use FOIL. So the radical's gone on the left side. We have 6k plus 19. But this means we have 2 factors, so x plus 4 and x plus 4. And we're using FOIL. First, that's the x and the x. Outer, x times 4, so that's 4x. Inner, 4 times x, that's another 4x. And last, 4 times 4, so that's 16. So when I simplify this, we get 6x plus 19 equals x squared plus 8x plus 16. So we're back to what we did on 24, where we have to make it equal to 0 and then do your x puzzle. So when I make it equal to 0, I'm going to say minus 6x. I can go ahead and line that up with those x's here and minus 19. So this now cancels on the left. Sorry, there we go. So our 0 is equal to x squared plus 2x minus 3. Now we're doing the x puzzle. All right, so what I'm going to do is I'm just going to open up, like we did on the last test, some just practice problems on quizzes, and then so you can see what type of style of question you're going to see. And then it's going to be the same kind of setup on the last one. You have redemption options. You can retake. Okay, you can use your review or any notes that you make. If you still didn't finish the decimals, please get that done because I'm going to turn it off today. And if you have no work, it's not going to be graded. You had to show the work and it checked the work that you did in the slide or you've turned into your paper. Okay? All right.